uh, and then um, and then yeah, we'll do that. And then we got an owl biddy, which is we just bought this new thing. It's really cool. So the people that are in are sat in the room, and then it has this really weird habit of like zooming in on when someone's in the middle of speaking, like zooming in on their nostril or something to keep you entertained. So kind of like that. Okay, let's go, Tom.
Great. And that's the exact reason why I've opted to not be in the owl room because
Oh,
of
well, you don't want it zooming in.
unfavorable camera
A
angles.
fascination with your nostril hairs or something.
Can you just let me share, please?
Yeah. Okay.
Cool. So, um, this presentation is going to be mainly, it's kind of broadly about my PhD overall, but I'm planning a new eye tracking study. It's going to be good to get some feedback on my plans for that. So I've not started yet, but kind of in the process of getting the eye tracker set up and thinking about my analyses for that. So we'll talk about that near the end, but going to kind of give a broad overview of what my PhD is about. And I'll talk more about what I mean by this is how we kind of process temporal structures. Children and adults generate predictable structures, but we also are sensitive to regularities in our environment. So we also perceive predictable structures. So I'll be talking about both of those things. So a little bit about how we generate, because that's been the earlier part of my PhD. And then we'll be talking a bit more about these observational processes. So touching on statistical learning, and also talking about event segmentation and hierarchical event segmentation, and then tying it into the current study, then thinking about narratives, which I think are a type of hierarchical event structure, and its relationship to attention. This has been studied a bit previously, but I don't think, to my knowledge, not at such a way of thinking about it in terms of hierarchical event structures and thinking about the mechanisms of why narratives support attention. So that will take us into the eye tracking study. So yeah, just what I was saying, temporal processing. Here, I'm going to distinguish between generative and observational. I know that someone might ask, well, they're probably quite interlinked, and yeah, I think I'll probably touch on that later in my PhD. But just for like for the ease of explaining here, I'm going to separate it and talk about generative processes and then observational processes. So generative will be kind of how we generate predictable series of actions. And to think of an example of this, when you make a cup of tea, you use a predictable series of steps. For instance, boil water, brew tea bag, stir tea bag, add sugar. And yeah, I think I'm probably going to retire the onion example. I think everyone here that's been here in the lab has probably heard my example about like chopping onions plenty of times, but I'm now switching to the tea analogy. But that would be an example of a predictable structure that we generate as well, for instance, in cooking. But it could be like, it's pretty ubiquitous that we use predictable routines in our daily lives.
Fun.
So yeah.
Is it so here is it like predictable for other people then?
Sorry. So well, in terms of like we perceive them to be predictable because they're performing a like so yeah, I mean so and when I'm talking about generative, I'm talking specifically about the actor of the generative behavior. But then I will be talking about how people perceive action and like perception of action or that yeah, action understanding will kind of form more under the branch of observational processes. And as I said before, you can see how that relates. And you know that it would relate to generative processes, and that's something that I try to argue in a theory paper that I'm working on. But here specifically, when we're talking about generative, it's how the agent then performs or generates a sequence of behaviors that's predictable.
But I was thinking the same thing actually, Tom, because it is an interesting, so you've been doing it with the Duplo, yeah, where it is just a
Yeah.
question of like, it's not from the point of view of the child itself, it's predictable from the point of view of I've seen this series of numbers.
Yeah,
So
yeah,
good, like, so Billy, who might be looking at, predictable play, that you'd have to, because when we're looking at kind of like observational things, like this book on concentration I've just been doing with Gemma, we're talking a lot about this idea that if a child can understand what they're watching, then how that affects their concentration. Yeah, so that's observational predictive, which is much more informed by understanding. Yeah.
Yeah, the understanding.
But it's not the case that all generative is nothing to do with. There's two ways of doing it. I can either like externally be from the outside looking in and saying, can I predict what's going to happen next? Yeah. Or I can say, okay, from the point of view of the observer, can I predict what's going to happen next? Yeah, but it's not like you can look at both. You can look at both generative and observational both ways. So I explain that really badly.
Yeah, I agree. So I think I don't know what the response is there, but yeah,
that's really hard. That's always really horrible because then if you say yeah, you did it. Anyway, hopefully,
it's a good point. It's a good point. Yeah, something to think about. But yeah, just in this case, yeah, like we'll be like thinking about it a bit more simply, and yeah, as I say, there is probably like a caveat in terms of there is that caveat when we're thinking about generative behaviors. It's actually what we have perceived to be predictable. And I think, yeah, I guess I'll probably just, talk a bit more about that generative processing now, and what's been done on it. So actually, it's really not a very expansive literature. There is some evidence to show that when sampling new objects, for instance, toys, that they show predictable sequences of behavior. But there's really not very much. I think those two studies that I've cited there are kind of the only studies. And one of those studies, this Linda Smith paper, is actually with dyads. So it's not truly looking at like the child's own generated behaviors. And like when I talk about generative, I really don't mean copied behaviors as well. So there's plenty of imitation studies. And so they would be like generating a predictable series of actions. But I don't mean that here because I'm specifically referring to, like sequences that have been generated by the child. But yeah, basically what we do know is that children can actually be quite highly predictable at an early age. And so I'll be talking about some of my early research where we're starting to build this hypothesis that that children start off being very predictable with object sampling behaviors, but become more flexible or more hierarchically organized over age. And I'll explain what that I mean by it in a second. And it's not until 5 years. Go on, Sam.
Well, I just was going to say that something we never talked about is language. So, we're just talking about like two studies that have looked at which toy do children use to play next. But, there's a lot of overlap with the language production. And it's similar that, Ishmael's favorite paper about, canonical babbling in autism, like early language production is highly, actually, is it? But it's more predictable.
Yeah.
And then it's the same. So it's the same transition, is it? I'm not sure.
Is there a question stated to me?
I think it was sure.
Did you say sure?
Sorry, I thought you asked a question referring to me, but.
Well, I mean, since you walked into it, I mean, is it? It's early language production more. You know what I mean. Your favorite paper.
Canonical babbling paper that you like in what's the term?
Yeah.
What does it say basically?
Okay.
Is it generally as a rule that like
I mean,
the complexity in the same way that Tom's going to be saying, if you get them to stack Duplo pieces, they start off by doing very predictable. So they stack a predictable thing, and then as they get older, they diversify into more, complex forms of predictability. Yeah. Can you make an analogy to language production that early language production is more, concrete, and then the generative complexity increases as they get older?
I can make predictions, but I mean, I'm guessing that there's some kind of a component about the reciprocity in the relationship, about like emotional exchange missing or not so high, that makes this language acquisition process more like a statistical learning model as opposed to what Marvin was talking about, the environmental learning. I mean, so those predictability instances are not very much based on interactions, like emotional exchanges or stuff. So I think it's like accumulated, the sequences of words or other things, I'm guessing they're not so much tied to emotional processing as much as kids who are less likely to become autism in later years. I don't know.
That's the point where it breaks down, isn't it? Yeah. Anyway, sorry to jump in, RJ.
No. So, but as we're saying, there's also on that, I mean, it's also anecdotal. So, for instance, like toddlers repeat things a lot. And I was thinking about the language examples because, yeah, that is like a dimension that I've not really thought about that much. I've definitely been more non-verbal, but thinking about that, I'm pretty sure that, you know, like if you hear like preschool or younger children, they tend to like repeat themselves a fair bit. Like just, you know, anecdotally, it seems like they like to repeat certain topics of conversation or stay stuck on certain topics for long periods of time. I'm not sure how much that relates to this, but that might be interesting. But yeah, it's not until like slightly later that children show evidence of being able to organize their tasks hierarchically. So for instance, some of the work by Lisa Ann Schroer, who's now at Erasmus, and this is not self-generated sequences, but just shows that, well, basically is just evidence that children, when given a task that requires some kind of hierarchical organization, for instance, building a Duplo house, it's not until 5 that they show better flexibility, i.e. are able to kind of switch between sub goals, so switch between like building the wall and then building the roof, whereas like the younger children seem to get kind of do the sub goals quite well, but they can't kind of piece those sub goals together to achieve like the overall goal of building a house. But then talk a little bit about the study that I've been doing so far. And well, this Katie Lancaster and I have been doing a lot of these home visits, going around to the participants' homes for the participants who've been taking part in our ANAXA project. For anyone that's new, ANAXA stands for, I can't even remember what it stands for, but it's a big like European Research Council longitudinal project that a lot of us have been working on. And we replaced the lab visits that we had at previous stages with this playpen interaction with joint play and solo play, and give them 10 different pieces of 6 different toys as presented in these stacks here. The data that I'm analyzing is based from the solo play condition where the parent has no influence on the child's play, or we tell them not to have any influence on the child's play, and we look at we code the sequences of which specific toys they touch. And this is also doing some, I'm also doing this for some extra data collection for 2.5 to 4.5-year-olds. Hopefully going to do this at the same time as the eye tracking study that I'm going to mention later on, although I've already started doing some data collection without the eye tracking. But yeah, basically, I'm not going to go into loads of detail for this, but feel free to follow up and I will try my best to remember how I did this. But basically, long story short, children are predictable, more predictable than chance. So if we measure their predictability as measured as entropy versus a surrogate distribution, which is based on their shuffled sequences, then basically across the group, they show lower entropy than chance, so are highly predictable. However, pardon me, if you generate another type of surrogate distribution that represents high repetitiveness. So here that's done as a Markov chain generated sequence where they are very likely to loop on the same object before making a transition to using a different type of object. So this is overly like highly repetitive, lacking flexibility. And if you generate a surrogate distribution based on that, they don't show any difference to that. So they're not very different from chance. Long story short, is that they're highly repetitive, but they're basically showing this kind of behavior where they are like looping through all the pieces of each individual toy and just building like very homogeneous looking towers at this stage anyway. But one of the predictions for the further data collection that I just mentioned up to 4.5, one of the hypotheses there is that they actually become less predictable. Did you have a question, Sam?
No, just go back. Sorry, I just looked at the x-axis. So real versus shuffled.
Yeah. So this is so I'm trying to remember myself. But basically, this is the average Z-score difference. So taking the Z-score of each participant's entropy versus so a z-score is like a relative difference to a distribution. So the distribution in this case is a distribution of entropy values, 10,000 entropy values. So you shuffle the original sequence and then you calculate entropy. That's one of the values, and then you do that 10,000 times to get a surrogate distribution of entropy values to then compare the difference to.
So basically below 0 means less predictable than chance, and above 0 means more predictable than chance. Okay.
Yeah.
So sorry, wrong way around. Below 0 means more predictable than chance. Yeah. So basically, so if you do just like a random compared to a random number, they're more predictable at 30 months. But compared to always stick on the same thing that you're on and continue doing that, then they're less predictable.
Sorry, we say that again.
Basically, there you're saying that if you do just like compared to completely random numbers, they're more predictable in their object choice at 30 months.
So they're more predictable than we don't compare to completely random, uniform random, but we compare to like random that's relative to each individual. So it's not like to uniform random, but to random that controls for the 0 order frequencies. And so, basically, they're definitely predictable. But then when we do this other kind of surrogate distribution, which is different to the shuffling, which is using this predictable Markov chain, they're not really that different to that surrogate distribution. So they're basically showing that they're not showing.
Sorry, Tom and Marion are doing a home visit. Tom, can you mute yourself? Yeah, thanks, Tom. You did it somewhere quite down, but anyway. But just quickly, you've got joint play data on this as well, but no one's coded that.
So we've coded the object selections, we've just not analyzed it for the participants that I've done. But I've been thinking about stuff for that, but not concrete, but I guess we could talk about it. Yeah. Not now, because it's really not concrete, my thoughts on that. But anyway, moving on. So that's one element. But then I guess really what I've been really interested in from the start of my PhD is sustained attention, but then also how comprehensibility relates to sustained attention. Then thinking about the factors that make something comprehensible kind of led me on this process to then thinking about how we perceive event structures. And so, this is all about observational temporal processes that event structures are going to come under. Basically, there's a lot more work on how children are sensitive to predictable structures that are created in lab paradigms, so for statistical learning. So there's a lot of stuff on that, and it does suggest that via statistical learning that children can kind of chunk together temporal information and perceive units of different units are unified as coherent wholes. I'm not explaining this very well, but then there might be other temporal integration processes involved, such as I'm not explaining this very well. So the statistical learning might relate to event segmentation, but then also event segmentation might just be like a different way of integrating temporal information. I think I'm just going to have to go into it and show. I don't know why that doesn't work sometimes. But just to give an example about how children or young infants even are sensitive to predictable structures or sensitive to temporal structures that they observe, I think this paper is a good example. So they showed them a continuous corpus of these daily actions. So for instance, in this case, it's someone picking up a towel and hanging it on a hook. And they gave like a familiarization corpus of the continuous actions. And then at test, they would pause the video either interrupting the action or at the completion of the action. And children who had been familiarized would show a violation of expectation look when the action was interrupted. So if you paused it in the middle of the action, if they had seen the training corpus, they would kind of look for longer. Versus when you pause at the end of the action, they were actually just more likely just to look away. And in this study, it was a result of learning from the familiarization trials. But then it leads to questions as to how they're able to segment. So the fact that learning was necessary, kind of in this study at least, kind of rules out that there was this inherent understanding of action, because familiarization was necessary. But what the authors suggest, and kind of what it seems like, is that they're making use of like low-level cues to like, but basically they're making sense of, like, it's basically that when there's like a change in, for instance, motion, is when they were most likely to look away. So that's what they speculated, is that that it was due to changes in like low-level features like motion. But then or it basically like that it's to like they learned a statistical relationship between they basically were tracking like the regularities of the low-level cues, and that's where statistical learning comes in.
I have a question or a comment. Does that have anything to do with attention and surprise? So, an interrupted action is a surprise. And when you look at attention in children, or when you look at attention, there is an element of surprise and novelty that factor in.
Yeah, that's exactly it. So it's like it in that it's a violation of expectation, is that it's surprising. So like that's what the assumption is around VOE effects, whether it is like actually like genuinely a surprise for them. I think you can think about surprise in different ways. Is a pause at a certain point was unexpected, and therefore surprising, leading to longer looking because it was surprising. But then so the reason that would be surprising is because they built up a statistical relationship of like they'd learned they'd learned like the regularities of the low-level motion cues, and that pausing disrupted that statistical relationship, and so then they were showing surprise looks. So then that brings us in. Is that okay? Does that answer your question, Candice?
Can you show the figure just one more time from the last slide?
Yeah.
Yeah. How comes the mean looking time is just quite a lot different to the mean looking times that we're typically kind of used to thinking about, like 20 plus seconds?
I don't know.
But just because it's a whole video, I think.
Yeah, but so in individual, is it done with an eye tracker, or is it done just with like?
No, I don't think it's done with an eye tracker. No, I think it's
So it's just their head orientating towards the screen, roughly.
Yeah, I can't remember the specific details. But
Okay.
Yeah. Is that all right? Yeah, sorry, I didn't know any better.
Yeah, so no one does like a smaller fine-grained stuff to move the movement within that, if you're saying it's
So people have, I'll get onto the eye tracking evidence, but I guess people have for adults, not for infants, but I'll get onto that. But yeah, just to talk about statistical learning, because this is what the authors would have said was the reason why the children had learned to form a cohesive unit of those different actions, and it's what a lot of people have suggested, well, some people have suggested underlies event segmentation, despite there not really being much specific evidence for that. But yeah, statistical learning is a big area of study. It's been studied in auditory domains for language, that I'm not going to talk about much here, but then also visual information. And it's all based on like artificial screen-based tasks. But basically, they usually show that children can form cohesive representational units based on transitional probabilities being higher, on holding groups of units together, and they can kind of form cohesive units based on that. And they can also generate predictions based on statistical learning. So if, for instance, if there was like a 3-part sequence that was highly bound together by transitional probabilities, if you showed them the first 2, they'd anticipate the last one, but I'm not going to talk about that much either. But I'm not sure basically what all of these studies show is more that you can create that basically statistical learning can be sufficient for forming these kind of chunks of temporal information, like you can, and it's sufficient for like causing the child to generate a prediction, but there's no, I don't know, someone can feel free to correct me, but I don't think there's a single study that's tried to like look at because it's really hard to do, is to generate, like, to look at the statistics of like statistical learning of sequences in the wild, in the environment, to see if there's like a specific relationship between yeah, like event representations or predictions, and like the and the transitional probabilities of regularities that people perceive in the environment. But then also, sorry.
No, I was just gonna say, so Katie, this is something you could look at, right? So do you want to just say quickly what?
I guess you could try to. I don't know.
Yeah. Do you want to just say quickly these new analyses that you emailing me about?
Yeah, sorry, I'll say quickly. I don't want to derail it too much, but I'm trying to quantify caregiver predictability, the predictability of caregiver behavior, and through like similar models through the Markov modeling, Tom, and then try and like chunk the behavior into more predictable on average or less predictable on average somehow, in terms of like looking at the transitional probabilities between certain states, and then try and look at how the infant reacts to these different to this like change in behavior.
So it's basically like similar to the nice Tally Barham stuff about, you know, where with the pups. Do you remember someone from her group in LA was presenting for us, and they code the different types of maternal behavior into, now she's licking the pups, now she's bedding them, now she's doing whatever. So Katie's going to be doing similar types of coding for that. So that's exactly, and then converting it to a series of numbers, and then looking at that, you know, how the changes in the predictability of these. And Maria is also setting up some analyses. We'll also look at this, because one theoretical point I was going to make was the periodicities are probably really important. And Maria, this is something you could look at, I think. So Maria's looking at just predictable environments and how they affect kind of development, but like the periodicities is something that they use to extract meaning too. Yeah. So Tom, you're just talking about if something happens and then something else happens, then do I use that to extract predictability? Yeah. But for a toddler, their conception of what a day is will be can be informed by the fact that the same things happen at the same time each day. Yeah. So Lisa's looking at kind of predictability in kind of daily routines. Yeah. And that will be also something that they use to extract meaning. So like the regularity, same things happening at the same time each day. Yeah. So it's a different type of statistical learning to what you're talking about, which is just, you know, one number to the next. It's like how the same patterns just reoccur in chunks, and you use that to extract meaning.
Yeah. Do you think that in a way relates to Bertiness? That in a, like, or like what people have thought about, but in a different time scale, thinking about in days?
Katie, you were talking about that in a meeting yesterday. Now, so I don't really get what you're talking about.
Yeah, I don't know. After Tom's presented on his slide, I'm a bit confused now how I look at it, but
yeah. Maria, Lisa, did you have anything you wanted to add to that? Because it ties in quite nicely to your stuff, but not if you don't want to. No, if you don't. No. Okay, tell me.
Not yet. Oh, sorry, I didn't know. I couldn't find the unmute button. I'm definitely going to have a look at these studies. They seem really, really interesting. So I'm going to have a little look to find out more.
Great. Cool.
But yeah, basically, long story short, statistical learning seems like it's plausible. You know, and you can show that children can like track these transitional probabilities. It's difficult to generate the transitional probabilities for things in real life, but also in things like Baldwin study that I just mentioned before. There's not necessarily evidence there that that's what they were doing, and statistical learning of the low-level features was the reason why they were sensitive to the structure of action in that case. So that link is yet to kind of be closed. But then just to talk a bit, like this is a specific, like, I'll not talk too much about this. This is like a specific example of visual statistical learning. So they have a continuous corpus of this starfish doing different activities, and so it was continuous, like non-stop, but across that corpus there was full units, so 3-part units that were bound by very high transitional probabilities. So for instance, like bow, clap, backflip always happening together. You know, every time bow happened, clap happened, and then backflip happened. You know, they had they always were bound as a 3-part whole. But then this across that you could and there was also part units, so where 2 of the items of the 3 were bound by high transitional probabilities, but then there was a transitional probability of 0.5 between that and the 3rd item. So that would be basically spanning across the full intact units to create part units. And if you showed both at test separately, they look longer at the part units with a violation of expectational effect. The idea being that they had use transitional probabilities to form a representation of those three parts as a cohesive whole, violating that caused surprise, or that's based on the assumption that there is a violation of expectation. But that's just a brief. I don't want to go too much into that because it's just a brief example of statistical learning.
Tom, sorry, can I just ask quickly, roughly how old are those children?
In that study, I'm pretty sure they were like 10 months. And in this study, I'm pretty sure they were 8 to 10 months, roughly.
This is kind of the opposite of what we normally say, Sam, right? Like when we're working with nurseries, we normally say with those younger children, you want to be really predictable and repeating the same things all the time. And then only when they're kind of developmentally ready would you start to introduce a little bit more unpredictability and kind of unexpected things to grab their attention. This is suggesting from a really young age, they're still attending more to when something is slightly unpredictable.
I mean, interesting. Yeah, I never really thought. Yeah. I mean, because Rachel Barr did those nice studies that if you show a video to if you show the same video five times in a row to 10-month-olds, then they look more the fifth time than the first time. Which is that's the type of study I always use to base that on. But it is a really good point that I'm used to, and I hadn't noticed actually you said it, Gemma, but we, when we're doing like early years training, we always say that, like predictability improves attention. And this is the heart of Lisa's PhD, that predictability improves attention. Yeah. It's a really good point, actually.
Can I also add on that real quick? It reminded me of Pierre's presentation 2 years ago about the rhymes, like the songs. He compared rhymes with songs. And I remember something about, if I remember correctly, like there's a surprise element, but that's actually a violation of prediction. But it's when it happens repeatedly, the violation of prediction becomes the norm, which makes it more attentive for the baby, like baby attends more, right? Like predictability of surprise after a while. Like that's why I guess Peekaboo is still a good game to play.
Yeah, I guess you need like a trade-off, like going back on what Gemma was saying and Sam with like the video. I'm guessing they're not going to attend the 5th time more than the first time to any type of video. It also depends on the like information content of the video, right? If it's just like a still frame, I'm not sure they're going to attend all like more the 5th time. It's also a matter of how much they can learn from the content. So like Gemma said, if it's really something simple where you want to make sure they understand this first, if they have like low processing capability early on, but then you want to ramp up like, I would say complexity, like information content of, I don't know, whatever they're attending to alongside their ability. So it's like, I don't know, everyone's right, but it's just the two needs are there. Like you need uncertainty for attention to make sure they're keeping their attention, but also not too much. So it's, again, that Goldilocks stuff. I think Tom's going to present a bit later, maybe.
I'm not going to talk about Goldilocks specifically today, but I think, that's a really good point. There's also like, worth thinking just that I think that violation of expectation looks there. It's, I guess, one element of attention where in certain cases that, when that does happen, that attention is elicited because that happened. But I don't think that represents necessarily all attention. That, some attention is about kind of having a substrate to pay attention to, and I think having a predictable structure, like basically it's almost like when you have like an event in time is like analogous to an object, is that you pay attention to an object like you pay attention to an event. An event is something that we learn from predictability, but then I think I might just be rambling here, but then just on that note about like the 5th time or 4th time viewing it, I think with those kind of contents that I think Pierre, you touched on this, is like that's like really like multi-level complex information, is that there is limits on how much children can process or understand in one pass through. And maybe it's the case that in earlier iterations of viewing complex information, you're still kind of getting your base layer and then adding attention to the like increasing levels of complexity. possibly, I mean, this is just like kind of speculative now, but yeah, basically, I think that all of it's valid, is that, you know, predictable structures are useful early in development, especially. I think one thing that those studies that I was talking about emphasize is that children can really readily pick up passively patterns that are presented to them. And so I think it's like a great opportunity, or that means that in early in development, it's more of an opportunity for children to, like, they're kind of more malleable, more susceptible to predictable structures. So then basically it's a great time to teach them that. I'm not sure, I think I'm just rambling now, but anyway.
Yeah, but does that I think that answers the question, Gemma, right? So if it's something complicated, so basically everybody, Goldilocks, like everyone pays attention to stuff that they can predict some of the time, but not other times. Yeah. If it's something complicated, then presenting it. And Lisa, this is really key for you, yeah, for your PhD. So for those who don't know, Lisa's doing a thing on introducing predictable sequences into early years in primary. So if it's something complex, then repeating it again and again will increase attention, because they still won't be predicting it right, you know, all of the time, because it's complex. Yeah, so the more you repeat it, the more they'll pay attention to it, because the more predictable it becomes, even though it's still in the sweet spot. But if it's something simple, yeah, then repeating it will decrease attention, because they're already predicting it right some of the time, and so it's moving towards the left-hand side of the curve. Yeah, so it's like a three-way interaction between the complexity, the predictability, and attention. Yeah, so Lisa, that'd be great to put in.
Yeah, definitely. And I thought as well that because we're looking at it from nursery up until year 2, we could have a look at the different developmental stages and how they like respond differently to the predictableness of the environment.
Yeah, and the complexity. Yeah.
Cool. Shall I move on? So yeah, basically, event segmentation, we're talking about it differently here. So I think that the people have drawn the link between statistical learning and event segmentation, but I don't think there's necessarily any evidence to suggest that statistical learning is actually how adults segment events, which is mainly what have been studied. There's been very few studies in development. But basically, just to go about event segmentation specifically, adults segment actions or segment experience, such as like perceived actions, into meaningful units at coarse and fine temporal scales. So a lot of the studies in the past have just been like, can you just press with a space bar when you feel one meaningful unit ends and another one starts? And participants are actually pretty reliable at doing this, and you can ask them to do it at coarse and fine levels. So fine levels corresponding to, for instance, the actions of sub goals, or like, you know, the boiling of the kettle or the brewing of the tea bag, whereas coarse events kind of corresponding more to the higher order goal level. And it's hierarchical, so the fine levels are embedded within the coarse levels. That basically it involves temporal integration of information across those lower levels in order to process higher order events. There's been really little research in infancy, but one neuroscience paper suggests that unlike adults, that the brain doesn't seem to have like a hierarchical representation of events. So I'm not going to go into that because it's like super complicated modeling work. It's quite cool stuff, but there's no like really that much kind of behavioral evidence. It's really hard. You can't ask young developmental groups to press a space bar when they think that one event ends and another one starts. There's no research in the preschool years either, other than this study that was in infants. But then just to give another example of that, so for instance, if they had one actor doing daily chores, for instance, folding and doing the laundry, or building a Duplo house, which is nice and topical, or setting up what looks like a very old game console, is that you basically ask like a bunch of participants to say when they think one event ends and another one starts at different timescales, and then you can see that actually the answers seem to cluster around certain points. So you can find points that are most probable for having been a coarse or a fine boundary. And basically then the thing about that is why I'm now trying to separate this from statistical learning is that it's not necessarily that you have to learn a regularity or like form a cohesive representation of regularities, but actually just be sensitive to change in motion. So sensitivity to change in movement variables is really predictive of segmentation at fine grain levels. So it's saying it like the lower level of the hierarchy, we're kind of more just processing. It is statistical learning in a way, but we are kind of processing like a fine-grained like change in motion, or like we're sensitive, we just like more sensitivity to like the real low-level like features. Whereas like the higher levels at coarse grains are less influenced by movement variables, and in other studies that I'm not going to show here, they've shown that it's more influenced by prior knowledge and learning at the course level. But then this would kind of account for the Baldwin findings that we found before. It's that when they detect a change in motion, that's when they're likely to segment. And so they look away at the end of the action because it represents a like the frame where you've finally ended that action. It represents like the greatest change in motion variables possible. So if you go from in motion to not motion, that's a change in movement variables that then infants might be sensitive to that change in movement to then make a segmentation. And that also makes sense that infants would be using that method because it's at the fine level of the hierarchy, the level that seems to be pretty invariant to learning or experience. Does anyone have anything to say about that? I don't think I explained it in the clearest way, so feel free.
No, that was good, Tom. Just quickly back though. So back to this idea of that, yeah. So back to the idea I was mentioning that another area of this is the temporal regularities, yeah. So the coarse grain one very clearly has got an event every 20 frames, 25 frames, yeah. So has anyone looked at that? Do events tend to happen every so often, yeah? In the same way that Pierre's nursery rhymes paper that someone mentioned earlier was, new information gets presented, and you can tell that there's new information and that there's oscillatory patterns. New information gets presented every so often. This links again to so Lisa, that for teaching there might be a thing where you have a new phonic sound and you say this is what it sounds like, and then this is what it looks like in a word. This is how we write it. And then this is how we can find it on a board. So you go through a predictable sequence of actions in a predictable order, but you also spend, 30 seconds on each. Yeah. So they learn a temporal expectation as well as something's followed by something type of expectation. So is there any literature on that as well?
The only thing I can think of analogous to that is actually the comments, and not on the perceptual side, but like I can't think of anything in terms of that. The only thing I think is similar is the Commons and Rasmussen Smith paper, where they did the topic comment structure. Is that they had like a predictable, there was periods of it's like burstiness basically, and that's the only thing I can think is analogous to that, is where they had periods of predictable sequence generation followed by interspersed with more random periods of exploration. Is that kind of similar in a way? But that's more like self-generated. Yeah. But yeah, I can't think of anything in terms of. What was the question like specifically?
Well, just about the rhythm. So if you look at the spikes on that bottom plot, yeah, they're very periodic. Yeah, so there's a coarse-grained event, pretty much exactly every 25 frames. Yeah. They're not looking at the temporal expectations at all.
Yeah. Then so but it still depends on how the actor, if they're just sensitive to the So are you suggesting that it's more there's periodicities in when they're more likely to perceive an event, or is it more that the actor here is being quite periodic and that the participants are sensitive to it? Because I think that's another important point.
I don't know, but Pierre's nursery rhymes paper was, the reason that nursery rhymes are a popular format for conveying information to kids. So Pierre, say if you don't agree with this interpretation, but basically the reason that nursery rhymes are a popular format to kids is that you get new nursery rhymes have got like a verse and a chorus structure. So every so often you get new semantic information. So Pierre did some really nice analyses that if you look at the rate of change of information complexity, it's got this periodic cycles. Yeah. So one of the things that helps children to find their way around new information is if it's got these periodicities. Yeah. Do you agree with that? What I just said about your paper?
Basically, like comparing the difference between those like periodicities in adult-directed song and children-directed songs, and we found that they were more isochronous in child-directed songs. So like supposedly more predictable. The predictability pattern itself was more predictable. So it's a bit, like second order zooming out.
Yeah.
I was just thinking, Tom, in terms of this kind of finding that it's the changes in movement that are really important, you know, in this study and the one before about hanging up the towel. Like practically then, for like working with children and babies, does that mean that if you're trying to be really predictable, you should be signifying like transitions and things really clearly with movement? So like for Lisa's study of a teacher's doing like a sequence of things, like Sam just said with the phonics, should they be, you know, sitting down for part of it and then standing up for the next part and then moving over there for the next part, so that there's those like physical cues as well? Or am I kind of...
Yeah, I mean, it's hard to say. It's like I'm uncertain to what extent we can like harness hierarchical kind of structuring to, you know, actually like in a practical sense. I mean, I guess I'm going to try and argue that hierarchical kind of hierarchy, like having this hierarchical processing supports sustained attention, but I'm unsure that I'm sure that, you know, if you had more accentuated movements, you'd pay attention to those individual event boundaries, but I'm unsure how that would relate across the hierarchical structure itself. So yeah, I basically don't know whether that would basically, I guess I think that, yeah. So yeah, not a very satisfying answer, basically.
No, it's fine. I don't think I understand what you mean by hierarchical structure. What is hierarchy?
So just to go, yeah, so basically a hierarchical structure would be like the act of making a cup of tea. Oh, it's going dark. Oh, it's fine, I'll just do it in the dark. But yeah, but like it would be like a goal, for instance, at the top level, course level, you have the goal of making tea, and then there's it's hierarchical because that embeds sub levels. So the starting scale of like boiling the kettle and then bring the tea bag, adding milk, sugar, whatnot, is like related to the hierarchy.
Okay.
So, yeah, bound within the hierarchy. So
but my gut is, you know, if I'm learning, you know, if my higher order event is I'm learning the oo sound, yeah, I'm a 4-year-old in class learning the oo sound, and then my lower order events are I'm learning what oo looks like, I'm learning what oo sounds like, I'm learning what words has got oo in it, yeah, then the more clearly demarcated those lower order events are, the easier it is to extract the hierarchical higher order event. That would be my gut. So yeah, so Gemma, I'd say yes to your question. Like that's why primary teachers very often do, you know, find like that's why they do a lot of, you know, signing. Like it's just a way of making what you're saying bigger. You know, it's not so much. So yeah.
I just had another thought about that as well. Is that you know, that it helps. This is really anecdotal, but for me at least, and probably a lot of other people that struggle to pay attention for very long periods of time, it's kind of good to break the task down and like write out an order or a list. So like if I found that, you know, this personally really helped me, and I know that other people it does too, is like to kind of list out the tasks that you need to do for the day and then break that down, like to appraise the importance of like how, I don't know, yeah, I'm not sure if that makes any sense, but then like looking at the task and breaking it down into its like subparts has helped me in the past. So yeah, I don't know, like appraising, or I don't know, highlighting how different sub goals relate to the higher order goal, or like highlighting the hierarchical structure in that case seems to help me pay attention on. I'm not sure if that's related to what you were saying though, in terms of like teaching, like I'm not sure how that relates in terms of, do you like teach children like the relationship between different hierarchical levels? Because I'm not sure if but anyway,
sorry there, Tom, what we can do is we won't get onto your eye tracking study yet, but we can save it for the next one because this is really interesting. Can I just quickly pick up another couple of things that this is other people's work that this goes into? So I'm now thinking about like Marion and Tom, your work on like physical movement and the early development of ADHD, yeah, I'm just wondering what the relationship is between what Gemma's saying, which is when you're watching someone do stuff, yeah, you're watching a teacher do actions as they're teaching stuff to you, yeah, and you're using that to help to segment and to extract meaning from the different units of event that's happening, yeah. And there must be some cool stuff we can do just from your free play interaction, because so one of the things that Tom and Marion are looking at, and Martin and Emily, who are not here to testing, but they're looking at how, like, early in development of ADHD, our movement patterns are atypical before there's any evidence that our concentration patterns are atypical. So their grant is looking at what's the relationship between movement and the formation of attention. So there must be some interesting links between what Gemma was just saying about the passive perception of movement, yeah, and then how I'm actually orienting myself to objects in my environment to help, you know, create attention episodes. Do you see what I'm saying? Yeah. And then, yeah, Maria, sorry, everything that's said here, that's there's links to that, you know, Maria's just setting out to do some stuff on, you know, predictability in home environments, and like all of this is relevant for you, Maria. You can have a lot to chew in your end.
Yeah, exactly. Now we need to pick what to do, but
Yeah, I know, we need to focus, but all of this is really relevant, yeah.
I'm glad to hear it's relevant to a lot of people's PhDs. But yeah, I got to this point before, didn't I? Yeah. Okay, so yeah, like it's very predictive of that low level of the hierarchy. This might explain the results of Baldwin, where, you know, they kind of speculated, but it offers a good explanation, is that you track change in motion variables that helps you segment, or in like basically it helps you segregate like temporal information, which then might help kind of the representation of that temporal information. I could have gone further into, there's like a bunch of neuroscience about that. If people are interested in that, they can email me, because I've read a few review papers about the actual neuroscientists that might be involved in that event segmentation, but I won't go into that now. But yeah, I think this is probably a good place to end it, 'cause after this I'm going to start talking about eye tracking work. So like, long story short, it's like, yeah, we're pretty uncertain about how children perceive predictable structures. We can like understand how we can create a structure that children are then sensitive to. We can create the conditions for learning like these like event units, but we don't know that that's actually what's happening when, for instance, we perceive like the discrete event of someone making a cup of tea, and we don't know that that's specifically what's happening in studies like the Baldwin paper. And we also know that, but we do know that adults pass experience it fine and coarse scales. It seems to relate to motion variables, especially at the fine scale. We need a lot more work in developmental groups, and that requires new methods. And hopefully that'll cue on my next lab presentation about the eye tracking work. But yeah, we know there's a relationship between attention and event unit perception. We're more likely to look away when an event ends. As I was saying, that example about thinking about events as objects, you know, that events are like temporal objects, that having a representation of that temporal object is the substrate of attention. And so I guess that's kind of what I was going to go into in terms of, oh yeah, I can talk about this stuff. I've got 4 minutes. Yeah.
Actually,
very briefly, it's just that.
I mean, that leads into the next one. Can we say that the next one? Because I was something I wanted to talk about, if that's all right.
Yep.
So for Noreen and people, so we've been talking about how children perceive predictability, yeah, in their environments, yeah. And then we've been Tom's been talking about this statistical learning X is followed by Y, yeah. And then we've been talking about this other type of predictability, which is periodicities, yeah. So every, 10 seconds X happens, yeah. So that's another way that they can extract meaning. But then in the paper with Katie Lancaster that we just done, we talk about 3 types of predictability. The other is contingency, yeah. So has anyone got any thoughts on whether, so like if I do X, then Y happens in response? Yeah, that's the definition of contingency. So is this, babies or children learning to extract meaning from the world around them? Yeah, which is basically what's been Tom's been talking about, yeah, to cut it up into chunks, yeah. Do we think contingency plays a role in that too? Anyone got any thoughts?
It kind of reminds me of what what we were talking about with Marvin and how he's looking at statistical learning with those models that are currently passive. And if you also then allow for the for the model to make predictions, say in language learning, it would be to say something, and then there's a predictable response you could get back. That is then going to be part of like a big part of your learning, but that requires like some action for the infant, like it will be quite different to passively perceiving things.
Yeah, probably. So Mark, for those of you who weren't here, Marvin was presenting some stuff yesterday at Methods Club, some modeling work he's done where you feed in audiobooks and it tries to learn the statistical structures in language. Yeah. Anyone else got any thoughts on that? I mean,
I was thinking based on what Piers presented and a lot of what Tom is saying now, that if you just look at temporal contingency by itself, it's almost like we are missing the third dimension of the complexity of what is being presented. So we can probably like predict that if there is just contingency without a change in information rate, this is how behavior would be. Like it's almost like for the child to treat or attune to the situation, it's not sufficient for contingency to be there alone. There also has to be like novelty or an increase in the complexity of information, because just purely contingency does not tell us that that action that's coming is going to be new or something the child hasn't habituated to, right? It's almost like there has to be a contingency of new information or a change in complexity for it to be useful for the child's attention to be either grasped or held, if that makes sense. Because just contingency by itself does not have that information domain.
yeah. The question is if that applies to the, is it like a chunk of meaning, like what Tom's been talking about, extracting chunks of meaning? Maybe that's a level of complexity up. Is it interesting chunk or something? I don't know.
Yeah.
But yeah.
I can say something on that, what Naren said, like there needs to be some form of a contingency, like predictable base. And on top of that, some portion of novelty. And that novelty doesn't, I think, necessarily have to be a novel stimulus. It can be the lack of that particular stimulus, like in the peekaboo game, like lack of the faith. So I think the world is like that. We are not reinforced continuously, but intermittently.
Anyone looked at that, Tom?
Wait, sorry, can you sum that up? Like, yeah, I'm not.
It's just saying like the violation of, as well as X is followed by Y. One of the key features that we use to extract meaning from the world is X is normally followed by Y. Now it's not.
Yeah. I mean, as I say, it's only been looked at in terms of in statistical learning. I don't think in terms of the context of contingency, but yeah, I think that like they've definitely looked at that. If that, yeah, there's a lot of studies in statistical learning based on like the omission of information and how there's a violation expectation effect on that, but not in the context of like contingency. I don't think like.
Yeah. Fine. I'm sorry. I'm just trying to catch up on I might leave the chat going because I want to see what's happening in the chat as well. Round of applause for Tom. Very nice.
Thanks.
Good stuff. And then Tilly, do you mind just putting Tom? You get about halfway through, Tom?
Yep. But if you put me on for a little bit longer, then it'll give me a chance to actually get some data, which might be just a bit more of an interesting topic.
All right. So do you mind adding Tom to the list, Tilly?
For like in springtime, maybe.
Okay.
Yeah. Thanks.
Okay. Really nice stuff, though.
Great. Thanks.
Bye. Well done, Tom.
Cheers.
Thank you.
Using the right weight matters.
Oh my God.
The body pod lets you easily understand what is the fastest way to
Yeah, that looks interesting, Tom. Yeah, I've got to go. I've got another meeting, but that is an interesting point. That So that's how it links in. You said that in response to what I was saying about the self-directed motion. Yeah. Yeah. All right then. I've got to go now another meeting, but I'll speak to you later. Yeah. Where are you, by the way? It looks cool. Okay. Looks nice. All right then. See you later. Bye.